Hello everyone. So in today's lecture we are going to see about logic gates using ladder logic. Okay. So here we'll be looking at different logic gates and we'll be also trying it out in the software. Okay. That is our TIA portal, right? See here there are different types of logic gates available: AND, OR, XOR, NAND, NOR, XNOR, right? So we will be seeing each one of them in detail, right? So here if you observe, this is our AND gate. In case of AND gate, the output is basically the product of both the inputs. So basically if you observe, 0 into 0, or we can say 0.0 is equal to 0. Okay, so the output is 0 here. 0.1 is also equal to 0, 1.0 is also equal to 0, and 1.1 will be 1, right? So the same thing can be observed in the electrical circuit also. Okay, so the logic gate symbol for AND gate is like this, right? And it will be having A and B as an input to the, and C here is the output, right? And if you observe the same thing in the circuit, you can see that when both the inputs are high, then only the output will be high. So if you observe here, when A and B both are 1, right, then only the output is 1. The same thing can be done using this circuit, right? In this circuit, if you observe, both the switches A and B are connected in series in a circuit, right? So when both the inputs are high, then only the output will be high, otherwise the output will not be high. This is what we are able to observe here. Okay, so if you observe 0 and 1, 0.1, that means if this switch is low and this switch is high, right, that means the switch B is in closed state, right? So this will be in the closed state. So if A is open and B is closed, then is it possible that circuit is complete? No, because because one of the switch is not closed, right? So in this case, the output C will not glow, or the lamp will not glow, right? Similarly, if you observe, if the input A is high, that means this switch is high, right? If this switch is high, that means it will be closed, and the output B is low, that means this switch is still open, right? So if you observe again, the circuit will not be completed, because even if this switch is in closed state but this switch is in open state, so the circuit will not be completed and the lamp will not glow, right? Similarly, in the last case, if you observe both the inputs, that means the switch A and switch B both are in closed state. So if both the switches are closed, then the circuit is complete and the output will be high, that is the output is in one state, right? So this is what is our AND gate, right? Now we'll see how to make this logic in PLCs, right? Okay, so here is our PLC, right? So we'll be making some PLC text before going into the logic. Okay, so first of all, let me open this program blocks. So we already know that we'll be writing the logic in our main organization block. Okay, so here I am writing it as AND gate, right? Okay, now what I'll do is, first of all, I'll make two tags, right? Three tags, basically A and B as an input and C as an output, right? So I'll be going to show all tags. Okay, now here I'll write first tag that is A. Or I can write input A. Okay, and I'll provide the address. Okay, so the address is automatically I0.0, right? Now I'll provide input B. Input B. So this will be our I0.1 input, right? Now we need the output. So output will be our C. Output C. Okay. So here we'll change the address as Q0.0, right? Okay. Now this all the tags are created, right? Now I'll go to the logic. Okay, here I'll see here these both the switches are in series, right? If you observe here, both the switches are in series, and this is our output, right? The same thing can be made in logic also. What I'll do is I'll take one NO. Okay, so basically the switch is in open state, so here also I'll take one NO. Okay, another NO. I'll take one more NO, for this will be the input number B and the output, right? So here if you observe, see this switch number A and switch number B both are in series to the output, and here we are giving from the left side we are giving 24 volt, and here we are giving negative to the LED or lamp, right? So the same thing is made in the ladder logic also. From the left side we'll be imagining that we are giving 24 volt here and we are giving negative here. Okay, what I will do is, in case of this, I'll write input, okay, A, right? So this address will automatically go there. Okay, now I'll write here input B. Okay, so I'll write I, and automatically I'll be getting input B. So both the inputs are in series, right? So this switch and this switch both are in series. As I already told you, this is our, we are imagining that this is our 24 volt supply. So this supply should go to this coil or LED. Okay, so this is our output. So I'll write output C, right? See here, now our AND gate is prepared, right? So what is our AND gate? Both the inputs in series, right? And the output correspondingly. Now what I'll do is, okay, let me save this one. Okay, and let us download this one. Okay, so this tags will be automatically loaded to the simulator. Okay, now I'll load the tags here, right? So all these tags are available here now. Okay, now one more thing we can do is we can just start monitoring the logic, right? Okay, so now if you observe, we'll observe the first state. So the first state is what? 0 0. That means both the inputs are in low state. So here also we can see that false and false, the input A and input B are in false state, that is 0 state, right? Now if I press one of the inputs or I activate any of the inputs, right? So this is our AND gate. Here even if you press both the inputs or first of all, if you press first input and we are not activating the second input, then our output will be in the low state. So if you observe, I am pressing this one. Okay, so here if you observe, we are pressing the input A. Okay, so here input A is pressed and the output is still not high. See here also the input is activated. That means this power is going from here to here, but this is obstructing the path, right? So this input is not active, that is NO is not allowing the current to flow from here to this output. Okay, so now now see this is our simulation table. Okay, the sim table actually. Now what we'll do is we'll observe by activating the inputs, right? Now see, first of all, initial state, that is both the inputs, input A and input B are in the low state, that means false state. See here, false and false, both the inputs are in false state. So our output is also in the false state, that means 0 state, right? Now when I will press this input, right, the input number A, will the output will be high. See, this power will go from here and this will allow us to this will allow the power to go, but this will stop the power, right? So here if you observe, we are having, now I am activating this input, right? So here let us activate this input. Okay, so this input is activated. See, this green line is showing us that this is allowing, okay, this input is allowing the power from here to here, but this input, which is not activated initially, is not allowing the power to go, and output is still in the low condition. Okay, now see, what I'll do is I'll deactivate this input number A. Okay, now I'll activate the input number B. Okay, so again the same condition, the power is this input number B is allowing the power, but the input number A is not allowing. That is why the output is not in high condition. Okay, so now what I'll do is I'll activate one by one. So first input is high. Okay, so the input number A is high. Now I'll activate the input number 2. So the input number 2 is also high. So see, the output number C is also in the high condition. So when you are pressing both the inputs, then only the output is high. This is what is our AND gate, right? So in this way we are preparing the AND gate. Now what we'll do is we'll try to make OR gate, right? So let us try to make the OR gate. So again, if you observe, what is the condition for OR gate? Let me go offline from here. Okay, so we'll be making changes in the same logic and prepare the OR gate, right? So here we will be also looking at how to take parallel, right? Let us see what is the OR gate. OR gate is basically A plus B. Okay, so basically what is happening here in case of logic gates, 0 plus 0 is 0, 0 plus 1 is 1, 1 plus 0 is 1, and 1 plus 1 is also 1. Okay, so basically what is happening is, in if any one of the switch is high, that is here if you observe, this is our circuit. Okay, so this is our output, right? This is our output. So if any of the switch is high, that means even if in switch number A is high, the circuit will be complete. See, if you observe, this circuit will be complete from here. Okay, so the output will start glowing, right? Similarly, if you are not activating this input A, and if you are activating the input B, then also the circuit will be complete. If you observe this in this way, this is the path, right? So in this way the circuit will be again complete. So again the output will be high. If both the switches are high, then also the output will be high. Okay, so what is happening in all the three states except when both the switches are in low condition, the output is high. Okay, so the same thing can be observed. See, in the last case, what we did in our logic gates, or in our ladder logic also, we placed both the switches in series, right? That is, both the NOs were placed in series. So in case of our OR gate, we need to place both the inputs or both the NOs in parallel. What I'll do is, we just need to place them in parallel. So what I'll do, I'll just click here. Okay, so in this way I'll just click here, I'll click this one. Okay, now what I'll do is, I need this output to be here. Okay, so I am pressing it here, right? Now what I'll do, I need to close this branch. So this is our branch close option. Okay, so I'll just place it here. Okay, or I can just click on this one. Okay, in this way we have completed our logic, right? So both the circuits are in parallel, or we can say both the inputs are in parallel. So if any one of the input is high, the output will be automatically in the high condition. So if you observe, if you are activating the switch number A, or we can say the input A, the output will be high. See, because the circuit is complete. From here the current will go and activate the input number or the output number C, right? See, similarly, if this is not active and this is active, so again it will become NC. That means it is passing the current from here to here. That is, output is high in this condition also. So if both the inputs are high, then also the output will be in high condition. Okay, so let me download this project now. Okay, after downloading, okay, let us observe. So I'll just monitor it. Okay, so let me just untick all this. Okay, so now initially the input number 0, or we can say I0.0, that is input number A, and the input number B, that is I0.1, both are in low state. That is, this is also NO and this is also NO. Okay, so both are in the 0 state, right? That is false state. Now I'll activate one of the inputs, right? So I am just activating this input. Okay, so see, if you observe here, this input is activated and the output is also in the high state, if you observe. Okay, so basically in OR gate, if any one of the input, so here let me change this one. This is our OR gate. Okay, OR gate. Okay, so if any one of the input is high, the output will be in the high condition. Okay, now similarly, again I am just deactivating this input. So again the output is in low condition. Now I'll activate the input number B. Okay, or we can say the input B. Okay, so again I am activating it, the output is in the high condition. Okay, similarly if we activate both the inputs, okay, so again if both the inputs are in active condition, then the output will also in the active condition. Okay, so in last three cases, only in case when both the inputs are in low condition, the output will be in the low condition. Otherwise the output will be in the high condition. So this is what our OR gate, right? Now what I will do is, I am just deactivating these inputs and minimizing this one and going offline again. Now we will be seeing about NOT gate, right? So when the input is in low condition, the output will be in the high condition. Similarly, when the input is in high condition, the output will be in the low condition. So this is what is our NOT gate, right? So now if you observe how to make the NOT gate. NOT gate is basically the reverse of the input. Okay, so when you are giving 0, it is producing 1. When we are giving 1, it is producing 0. Okay, so now how to observe this? So initially, see, the switch is not active, this switch is not active. So basically what we have done is, it is in NC condition, or we can say it is normally closed. Initially it is closed, that means we are not activating the switch. That is in 0 condition, the output is in high state. Okay, so now when you are activating the switch, it will open, because initially it was in closed condition, right? So when you are activating this, it will be opened and the output will be in the low state. That means when you are activating means what? From input side you are giving 1, but the output will be 0. Okay, so the same thing is here. Okay, so let us observe this in our logic. Okay, here we require only one input, right? So I'll delete this one. I'll just change this one, because why? Because this is required is normally closed. Okay, so in the circuit we saw, right? So we'll just change this one with NC. Okay, I'll just delete this one and I'll do here as input A. Okay, now see, I'll download this one again. Okay, now after downloading, I'll click on monitor. Let me see what is the issue. Okay, downloading, finish. Okay, go online. Okay, now see, we are online. Okay, so initially if you observe, when you are not activating this one, see here, we can see here. Okay, so our input number A, so this address we are actually observing. We are observing this address. So input number A is in low condition, right? So here also we can observe it is in low condition, we are in, that is false condition, but our output is high, that is it is acting reversely, right? So here if you observe, when you are not activating the input, the output is in high condition. Okay, now when you activate, that means I will just make it true. Okay, or we can say from 0 we are activating it to 1. Okay, so I'll just press this one. So see, now the output is in low condition. Okay, so actually it is basically producing a bar, input bar. Basically if you are giving 1, it is producing 0, and when you are giving 0, it is producing 1. Okay, so this is how we are using our NOT gate. Okay.